So the basis of this presentation is similar to what we give for AIA accreditation for continuing learning units. It has been crafted specifically to address the environment of conventional steel and pre-engineered metal buildings. So we'll talk about an overview of controlled environments and what that implies, and then we'll get into some of the specific detailing and issues in the market for cold storage work. So with that said, we'll kick off here. Essentially just a description of how we describe controlled environments. And really what this is just to imagine that the common belief in the market was cold storage were walk-in coolers and freezers that you would see in convenience and restaurant. That's quite contrary to what the cold storage market presents. That is an entire distribution model centered around food and beverage, food processing, food manufacturing, packing, storage, and supermarket distribution. This includes facilities that fall under anything under FDA or USDA guidelines, including feed all the way to seed processing. Anything that was tied to the food chain now has direct responsibility under controlled environments. How we see it as well is that, from expanding the traditional cold storage warehouse, there are lots of new opportunities, and the way that we do that is essentially completing the envelope. So when you're designing a cold storage facility, you have the structure, of course, but you also have the underfloor slab, which is part of the envelope. You have ceilings that are part of the envelope, and you have doors and openings that are part of the envelope. So all of those have to be addressed, and we just like to demonstrate that Kingspan has the largest product portfolio to allow you to do so. So if you have any other questions once you get to know us, or if there's particular applications that you may be looking at, just come to Joe or I, and we will help you find an appropriate product to fit your needs outside of maybe the standard products that you're familiar with. On my front, what we particularly address, you may see a few brands out in the market. The Kingspan insulated panels, of course, is the main staple of cold storage and controlled environments. It also includes Hercules doors, which is a brand of doors manufactured specifically for the insulated market. And then Green Guard is our underfloor extruded polystyrene product that we use to complete the underslab. Yes. Yes.
Audio dropped out. Your audio dropped out on my end.
Hang on a second.
Okay, I can get you now. I hear you now.
Is that better?
Yep.
Okay. Okay, so I don't know if you've missed any of that, but essentially we're trying to identify that the envelope includes the three products here, particularly by application and brand. Just some representative examples, of course, you guys know buildings and exterior, just a few examples of cold storage distribution, usually utilizing IMPs. More familiar would be this scenario, a large facility, white panels, dock, canopy, pretty typical for a cold storage freezer being used as the external envelope. So with that said, we'll get into the more technical items of the presentation. The wall panel assembly itself for controlled environments really manages four components. Familiar is the water and the air and the thermal, but the biggest one is the vapor movement. So vapor from a diffusion aspect moves more moisture from warm to cold than water, and that is really the key driver of designing around the envelope, whereas the thermal barrier is key, but that vapor barrier, which is part of the joint design of our product, is where we get the performance. So the better that the control layers are managed, primarily the vapor, the more successful the job will be. I'll pass over this. I think by now you guys are all familiar what an insulated metal panel does. But from a cold storage perspective and the importance of the thermal layer is that the cold storage envelope having a warm side and a cold side, the cold side being the interior and the warm side being depicted with the sun here on the exterior. The key is that when the building is exposed to thermal temperature, the panel itself will want to bow. So that bow goes towards the outside of the building. And the key to this is having enough structure in place to limit that bow. So when we design for span, which I'll talk about later, is that we'll make sure that the color and the thickness and the outside temperatures are all taken into consideration for that performance. But here just describes, again, reflectivity from the solar rays is key on a cold storage building, and that's primarily why you see most cold storage buildings as white. Typical cold storage alternatives to IMP, there really isn't a lot of alternative options. I've highlighted the two, which are tilt or insulated precast. Depending on the climate, one will be dominant over the other. IMP is conducive for every environment, whereas in the cooling climates down in the south, you'll have tilt, and then you'll have on the heating climates the insulated concrete. Whereas the panel is still a single component design, it does provide the best speed of build, best thermal, and best installation practice for cold storage than the other two. But instead of where you guys are competing mostly with alternate claddings and built-up systems, we run into these two as the primary alternatives. The design options for cold storage from the standpoint of thermal are again limited. Cold storage panels were developed first in the 80s, whereas it just became the best opportunity to provide thermal performance for a box to maintain temperature on the inside. So when you see the progression of the cores, you may be familiar with our Highline product, Quad Core, which is the newest and latest in thermal technology, fire performance, and thermal values, or environmental footprint. Prior to that were some of the more lower grade panels in the market for cold storage, and particularly you might come across expanded styrene panels, or EPS, which are used for interior and still accepted by code, but they are highly flammable and uninsurable. They also do not provide very much thermal performance. So as cores in the insulated panel have changed, the performance has gone up, and the PIR panel, which Kingspan makes, and the quad core panel as well, is the higher performing on the market. So the key attributes of the insulated panel that we're trying to highlight here: precise thermal control, which basically means if you have a negative temperature on the inside or a cooler temperature on one wall, that the panel will maintain that temperature through its thickness. Superior hygiene, we'll talk about the aspects of food safety and why hygiene is important, as well as the R value. The insulated metal panel provides the highest R value in the market to maintain those temperatures against any other type of material. And then again, vapor tightness is a key along with superior fire performance for safety and protection of goods inside the building, excuse me. As we talk about the design considerations and specifically where to use what, that is really what is at the core of the market, as defining what the application is and then what is the required thermal value or thermal resistance required for each of those temperatures and uses. So I've highlighted here the core thickness, the stated R values at 75-degree mean, which ASHRAE uses as a baseline on their 90.1 documents. And then on the cold storage side, we also test at a 35-degree mean temperature to better represent what the actual application of a cold storage will be. So you can see the incremental increase, for example, on a 4-inch panel from 29 to 32 R for that thickness. And then this correlates to the table on the right, where if we're talking about a cooler, which ASHRAE defines as 40 Fahrenheit to 50 Fahrenheit, it then calculates the thermal resistance required for each part of the envelope, which I mentioned earlier. The floor is one part, the walls and ceilings are the other, and the roof is the third. So on a cooler, which you guys will probably have the most access to and requirements to meet, for example, a 50 to 40 degree cooler only requires perimeter insulation around the foundation. It does not require an insulated concrete floor. The minimum requirement on walls and ceilings is R25. So you can correlate that over to the chart, and you're just at the fringe on 3-inch and you're then 4-inch panels for a cooler from 40 to 50 degrees. 50, you might be able to get away with 3-inch. And then, of course, the roof, 30 to 35, you'd be looking at 5-inch roofs if you were going to use insulated panels for a entire envelope structure to maintain a 40 to 50 degree unit. When you start getting into chill cooler, holding freezer, and blast freezers, which I've highlighted in the red box, then you start to get to some really higher thermal requirements for the envelope, as well as applying detailing, which keeps the continuity of the envelope intact. So just for example, we are a -10 freezer. You're at 27 degrees resistance at the floor and needing an R35 to 40 in the walls at a minimum. So you're already starting to look at 5-inch panels to go to -10. That's where we actually recommend it technically, and anything higher than that requires 6-inch or greater. As part of your program, you won't be getting into this holding freezer, blast freezer zone. If you get into those opportunities, we would advise and work with you to find a turnkey opportunity or contractor to do the entire portion of this versus trying to accomplish that through the building program. And I'll again touch on that on the detailing side of things. Just to touch on the food safety aspect, in 2012, the USDA and the FSMA was put in place, which is the Food Safety and Modernization Act. And really what this was doing was trying to protect the food chain from, at the time, was a massive amount of E. coli outbreaks and food contamination. You've heard of the listeria outbreaks with the Bluebell ice cream. So what it basically does is define what is a recommended use of IMPs as a non-contact area. And IMPs being in the room will have an indirect contamination of food products. So therefore it has to go through the cleaning procedures and the sanitation procedures. This is key only that you may have clients let's say in a packing facility that have their own initiative of safe quality food program standards, that then they may be asking you questions like, what should I be using in this room? Is this the appropriate product? Is this the appropriate detailing? And that's where Joe and I come in to make sure that you are using the proper finish and detailing for the application. Just a representative examples of the paint systems here. I really pulled this up specifically to show the limitation of the colors. And that goes back to the slide of that thermal transmittance, whereas if you put dark colors on the exterior of your building, it's going to absorb more heat, and that doesn't bode well for a controlled environment. Whereas if that bow incurs on that panel, you could breach that vapor seal. So a lot of the times, or most of the time, you will see the standard white product on a cold storage freezer box or building, and that's reasons for performance, not necessarily aesthetics. But if you did stay within the range of the standard Category 1 Kynars in the lights and brights, we can facilitate that as well, and make sure you get the right panel and thickness specified. I'm going to move on to the design aspects of the insulated metal panel for use in cold storage. Doesn't look like we have any questions so far, so I'll keep going.
Hey, Steve, Joe Moore. Hey, Steve.
Yes.
So the R value that you shown on the previous slides, was that PIR?
Yes.
It doesn't present quad core. So quad core is available through this partnership as well, which would be
okay.
a much higher R values.
Absolutely. I will touch on that real quick. The quad core panel, when tested at this 35-degree mean temperature, and when we say tested, we take a core material, and per ASTM, there's a requirement to test that core. The quad core product, in comparison to the PIR product, churns out a 9 per inch. So when you look at a 9 per inch, you start to see the benefit of the incremental thickness, or you may be able to get into holding a temperature at -50 per se, whereas you couldn't do it with a 6-inch panel. You can do it now with an R54 being the requirement on ASHRAE. So all of a sudden, you've got a wall that does meet some of the lower temperatures. The same thing on the quad core side. It also eliminates a conversation that you may come across, which is the long-term thermal resistance. And that's a term meaning that the core over time will lose its resistance ability, and the quad core basically eliminates that. So another offset of that is a thermal warranty based on using the quad core. So good point, Joe. We definitely have the 2 R values, and that was assessed based on PIR. ASHRAE doesn't care what the material is; they just care what the thermal resistance is as well. So the panel wall assembly and the enclosure functions, I use this slide twofold. One, it shows what the panel does compared to other properties, and as a composite panel, the IMP acts differently under load. IMPs are non-load bearing materials. They're classified as what's called components and cladding. So they don't have, or they have limited shear capability and express diaphragm differently. When loads are exerted on the panels, they tend to cup or or have what's called crossbow. So in order to eliminate that, we have the fastening and the connections and the end connections on each end of the panel that keep that from happening. From a cold storage perspective, the panels have to have support, and that's included in, let's say, a interior box in a building. You need to provide lateral support to structure. So when designing the IMP box inside the building, it has to be tied to structure, and it has to have address the axial and the lateral support in the ceiling. You don't have to know all of it, and we're here to help you understand it. We have technical staff that will run wall assembly span capability charts, components and cladding design based on the wind and the loading pressures, including the thermal. And then we'll take into consideration the temperature differential, meaning the warm ambient on the external and the conditioned negative temperature on the internal. This essentially, you guys are probably familiar with this, but it's showing the capable span of a ceiling under load of 20.1 pounds. Let's see at the top circle here on the 4-inch panel. And the rod spacing in the ceiling is addressed at 4 feet. And you can see as the table stretches out, the available product that meets those spans diminishes. So we typically see for, let's say, ceiling designs, a 10 to 12 foot span, and on wall conditions, another chart over here to the left is a chart that describes the interior partitions and their allowable span in feet unsupported. So, for example, a 4-inch panel inside of a building can span 33 feet by design on the interior without any other support. Again, just an example here of the components and cladding that we provide on the design to understand your fastening and where you're going to attach these panels. And again, to reiterate, on the cold storage side, we do this a lot more than we do on the industrial side because of the thermal temperatures involved and that deflection that occurs in the panel as the temperature is brought down on the interior of the building. So this determines the steel and the girt locations, and that's something you'd want to do on the front end of your design once you know the interior temperature of the building. So here's an example, representative example of structural steel design. This is a conventional design where you have a combination of column and beam supports, and then girders and purlins in this case in the picture to the left, and then installation methods here on the right. We have a minimum requirement for conventional steel and girts when we engineer the cladding, and we do that per ASCE 7-10 for wind and thermal to support the spans. Moving on to design considerations for pre-engineered metal buildings, you can imagine that the IMPs, of course, are conducive to this type of design. It was very prevalent on the West Coast when pre-engineered and IMPs met that it was the best practical application for speed of build, thermal performance, and 2, it can be used for controlled environments. The project there represented in the picture is a brewery front of house with the keg storage included within the metal building itself. So it is an opportunity to utilize products in varying degrees, but practically the practical design for a pre-engineered building is 37 degrees and above, whereas you don't have specialty refrigeration equipment. So The key here is, when you're designing around these buildings, I know you can put as much cross bracing in, or you can design it to reduce the drift or make it as rigid as possible. There's going to be a cost benefit from conventional to pre-engineered, at the point where if you have to load up the pre-engineered with too many purlins and girts, then it becomes cost prohibitive versus conventional. So you guys you'll be wanting to look at those two programs to see which best fits, depending on what the application is. But you do need to design for drift and bracing to avoid that rack and shear in the panel that may create a vapor leak in the joint itself. For the roofs, I just wanted to highlight here, the ridge and the end laps are not suitable thermal vapor detailing. We prefer on the roofs that they're single slope and limited to one panel width if you're getting into temperatures below 37 degrees. So we have panels that can go upwards of 55 feet. We can certainly do those in one slope. If you do need to have multiple panels, we do have thermal details for both our wall and roof detail projects that do address the ridge and the envelopes. I'm just saying they're very difficult to make vapor tight, and particular attention needs to be taken when doing them. As far as expertise, again, I'll highlight that when you're looking at packing, keg storage, beverage storage, where you're at 37 degrees or above, the details and the erectors that you're using are capable of putting these up. We just want to make sure we're following the thermal and the vapor detailing of cold storage. And then when you get into a scenario where it's a cold storage building or a temperature that's very low, we utilize the expertise of the market, and we can help turnkey that and get you the right people involved to have a successful project. The pre-engineered design solutions that I have here, I'm demonstrating from the lower diagram of what we just saw in the picture of the metal building just clad over wall and roof, and the holding temperature there between that. I said 40 to 50, but we can talk about 37 degrees or 40 degrees being the temperature. It's a cooler, and there's not a lot of risk involved with a breach in the envelope. When you start getting to the chill cooler, which is the 32 to 40, you'll see I've shown this liner panel and a drop ceiling. So we're encasing the environment closer towards the thermal envelope and eliminating the risk for temperature and vapor leaks. And then at the top diagram here, you start to get into holding freezers. You see the drop ceiling and the interior walls, and you'll want to be isolating that from the building itself, because the holding temperature must be maintained, and it's very difficult to do that on the exterior of the building once you get below that 0 degree barrier. You need to be doing it from the interior, like a box in a box is what you'll hear as the scenario in a building. Typical cold storage panel, same panel you make for everybody else, just a difference in thickness. That's essentially all it is. Typically white, which lends itself to a little more commoditized type approach, but it is available in varying widths, thickness, and gauges, but limited to color and application when designing a thermal envelope. I'm going to move on to some of the more minute detailing, which is really focused on the thermal. The two key areas in which are key to cold storage is the thermal breaks and the vapor seal. Those two combined are the key to a successful cold storage envelope. And as you see the diagram here, in a traditional installation, you have a left to right installation. you have 2 male females with butyl caulking, and it's that thermal break between the foam to foam that is key, and then the vapor seal on the warm side of this structure, which in this case would be the outside in the joint itself. So those two key things are the main driver of installation. I'm showing a representative diagram here of what happens when warm vapor gets inside of a cold storage warehouse. You essentially create snow. You have evaporators and fans running in there, and as soon as that moisture meets the air, it is like a snow machine. So what we do here is really be mindful of where that vapor seal is, and on the diagram to the lower right, you'll see in a typical application of an industrial facility that when you're heating the interior environment, you have the vapor seal on the interior side of the vapor barrier. On the cold storage application, it's completely opposite. You have the vapor seal and the butyl sealant on the warm side or the external joint of this building, and therefore the seal starts there and doesn't migrate all the way to the back of the panel. Whereas if you have the seal in the wrong spot or it's improperly applied, you can see where there's a vapor breach in this building. You have the photo on the left, which you can't see any visible condensation or leak, but when you put the thermal camera on there, you have a 20-degree Fahrenheit delta in that cool spot right there. That essentially means the installer or the panel is not going together at that point. There's not enough sealant to keep that warm air from infiltrating the panel, and the cold is meeting the exterior surface. So we can look at this as not necessarily a failure, but certainly a breach in the vapor seal at this one point that can be mitigated with proper detailing. Going through some of the details, I won't go through every bullet point, but essentially it just reinforces that vapor seal and thermal break, and I'll identify the areas which are key to doing so. You'll see in these renders that the panels are foam to foam with field foam in between a thermal cut into the panels themselves, and then underneath the flashing would be a butyl tape flashing or asphalt flashing tape underneath the panel itself, the trim itself, so that it creates that sealed envelope detail. Similar to the outside corner, the biggest one that we see in the market as a tough one to hit is this wall to roof transition. That's really difficult to get that foam to foam, that vapor seal from the roof insulation down into the walls, and that's got to be done perfectly to make sure you don't get any ice balls or drips from the ceiling. You might get owners that say, I've got the wall or the roof's leaking. It's not leaking, it's condensating. So it's really critical here in that wall roof transition, as well as in the ceiling to wall transition. We have proper details that make sure that continuity in the thermal envelope continues. And then similarly, when I mentioned continuing the envelope or completing it, that floor insulation to wall in a freezer application, you must marry that floor insulation to the wall panel through a thermal break and vapor seal, and then you have the vapor barrier going underneath and over the panel to create the envelope. Ceilings in particular are very common in the market. Our panels require you to use 3 inches or greater for a ceiling panel. We have a ceiling assembly, which is utilized to hang the panels from the structure above. And then the rods here that are sticking out of this T would be aligned with your purlin spacing. So if you were hanging a ceiling in a building, that's how you do it, attached to structure above. And then we could give you the dead loads, and then you give us the live load, and we assess what span and what panel is best to do so. But on the vapor side, one of the key areas of a sealing panel is to insulate the rods as well as the joint in the panel itself with a batten strip over the top provides that plenum space, the vapor seal that's needed to perform. Just an underside shot of this with the concealed sealing assembly. You can see the field foam underneath with the batten strip on the cold side, and on the warm side you have the tape on the top with the seal on the trim, and then you have the rod thermally insulated as well. So those are just some of the highline details. I know this was a kind of a crash course in food storage and detailing. We certainly can get into further detail if you guys have any particular questions. But again, to reiterate what I said before, the key to controlling that temperature in the interior of the building is mitigating the migration of warm temperature or warm vapor to cold. And that's the key to sealing up the envelope.